Dear students, today we will talk about experiments used to conduct pavement evaluation. Pavement evaluation. Now there are two kinds of evaluation. One is structural evaluation. The other is functional evaluation. So in this lab class, we will study two tests for structural evaluation. One is LWD, the other is DCP. This is light weight deflectometer. Other is dynamic cone penetrometer. In functional evaluation, we will study British pendulum, skip tester, and then we study about Merlin. So we will see what does Merlin stands for. LWD stands for, as I told you, lightweight deflectometer. So basically it's a quality control device for the field purpose. Field purpose. So it's a class of NDT. The NDT stands for non-destructive testing. So normally when you construct a highway in the field, we need to measure the density of the soil, subgrade soil and granular layer at very close frequency to maintain the quality. In that case, normally we do sand equivalent test. Sand equivalent test. But this is more laborious and time consuming. And also it will create a lot of holes in the subgrade soil granular layer. To avoid this, we use a non-destructive method called LWD. So LWD is similar to FWD what is in the class. Similar to FWD, but at a low impact load, low impulse load. So basically what we have a compacted subgrade, let's say. On this compacted subgrade, we place a loading plate, similar to FWD. On this loading plate, we will apply a load maximum of 20 kN. When you apply a load, subgrade layer will deflect. So, if there is higher deflection, that means the modulus is lower or degree of compaction is lower. If you get a very low deflection, then it is well compacted and its modulus is higher. So this way you can identify the quality of compaction or degree of compaction during the constructing subgrade at a very close intervals. So no need to do sand equivalent test at very close intervals. We can go for LWD so that we can measure the modulus also and also the deflection and see the quality of construction at the site. But due to low load as 20 kN, this is very applicable for unbound layers, unbound granular layers and soil. So LWD cannot be used for concrete or asphalt pavement because of the load, right? So moving to the equipment, now we have different components here. Now this is basically loading assembly, complete loading setup. We have a rubber pad here, right? And then we have a loading plate. And then we have this is called load cell arrangement, and also it has a communication device to communicate the data with this tablet, right? And then this is the buffer ring. The buffer rings are used to control the time of contact. Normally, when this load applies on subgrade, the time of contact is 15 to 20 milliseconds. So in this is a time of impulse. So this can be varied by varying the thickness of this kind of rubber. This is called a buffer rubber. And then we have this loading plate will apply the load on this particular system. And then this load is guided with this kind of rod. This is a guide rod to guide the particular load on this particular bearing plate. This is a component of LWD. So while doing test, you will fix all these things in a one single assembly, and then you will load on the particular area where you want to find the deflection or the degree of compaction. Normally what happens in the site, before doing this test, you will develop a correlation. At site, you will develop a correlation between degree of compaction and then modulus. So this will help you to achieve, if you know, degree of compaction or modulus. Let's say you design a 50 MPa modulus, design modulus, achievable at, let's say, 98% degree of compaction. So when you do a testing in the field, we can compare depending on this particular. If you increase the degree of compaction, you get higher modulus. Depending on this kind of curve, we can determine what is the modulus achieved in the field through degree of compaction.
This is the LWD setup. Initially, we will attach the bottom plate in a plane surface, for which we have to find the modulus and deflection value. Then this is the 10 kg weight. Actually, the reading will directly come through Bluetooth in this tablet. So first, we have to let the weight down. The reading, now you can see the reading on this tablet. Then again repeat the procedure. Please do it for 5 times for one location.